Well, here are the answers to the questions, the essay questions on exam 4. Just want to show you that they're important and you need to study these for the final exam. So, question 1 had a cable 100 meter long, a cross-sectional area of 1 millimeter squared. A 1000 Newton force is applied to stretch the cable. The elastic modulus is given. How far does it stretch? So the original length is given. The area is 1 millimeter squared. When you change it to meter squared, please remember 1 millimeter is 1 by 1000th of a meter. And because it's a millimeter squared, it's going to be 10 to the negative 6, which is 10 to the negative 3 squared. Young's modulus given, force is given. Just have to put it into this formula for Young's modulus. Change the subject, substitute the numbers, and it's quite simple to get that answer. So what you have to be careful about is the conversion of millimeter square into meter square. The extension is 1 meter. And that's because its original length is 100 meters. Now in the second one, water flows in the horizontal pipe as shown in the diagram. And the diameters at the wider and the narrow portions are given. And the fluid in the manometer there is mercury. And the manometer shows a reading difference of H, which is 4.40 centimeters. What volume of water is flowing through the pipe per second? When you are asked to calculate the volume of water flowing per second, you could do it in two ways. It's either the area of cross-section times velocity of the narrow part, or the area times the velocity of the wider part, because they will be equal. The idea is that where the pipe is narrow, it's going to flow faster. Now we also have to use Bernoulli's principle, and when we do that, you get, for a horizontal pipe, of course, Bernoulli's principle is written as P1 by rho plus V1 squared by 2 is equal to P2 by rho plus V2 squared by 2. So now make P1 minus P2 the subject, and I've just labeled this 1 and 2. Why are we making P1 minus P2 the subject? Because the difference in height here can be used to find the difference in pressure. So when you rearrange this mathematically, you're going to get rho by 2 V2 squared minus V1 squared, and P1 minus P2 is H rho G. Now there, rho is the density of mercury. So that's 13,600 times 9.8, which gives you 5864.32 pascals. So that's very important to know, that the difference in pressure. So here the velocity is smaller, the pressure will be higher. And since the velocity is bigger here, the pressure is going to be smaller. So P1 is bigger than P2, and it is that difference that you see in the manometer here. So P1 minus P2 is H rho G, which gives us that. So now take that back and substitute here, and of course this is the density of water, so 1000. So that gives us V2 squared minus V1 squared, and then we can use this equation to get another equation with V1 and V2 and then solve. Okay, so A1 V1 is equal to A2 V2. A is pi r squared. It's the radius in centimeters, so I've changed it into meter. And same thing on the other side. Okay, V2. Therefore, V1 is 0.64 V2 when you solve that. And then we got V2 squared minus V1 squared is 11.73. Substitute for V1 here. So when you do that, you are going to get V2. Well, this is a 1 minus that, so that's why it's 0.5904. From which you get V2 squared, take the square root of that, you get the velocity as 4.45 meter per second. And once you get the velocity, just do A2 times V2. That is A2, and we just got V2, so multiply with that, and you get the volume flowing in 1 second as 5.6 times 10 to the negative 3 meter cube per second. Now that's an important question, and make sure you understand this. Here we have a cubic box, side given, the number of molecules given there, and the mean square speed given, root mean square speed given. What is the average pressure? This is a direct question because you can find the volume. You have to have it in meters and meter cube as the number of molecules. The root mean squared speed is given. The mass of a molecule is given. So you're asked to find the pressure, and the formula for pressure is 1 by 3 mn v bar squared by volume. So since all these terms are given, you just substitute those into that equation. That's the mass of the molecule, the total number of molecules. Okay, you got to square the root mean square. Yep, square it and then divide by the volume. And you get 1.13 kilopascals. Can't ask a question that's simpler than that on the exam. Number 4, the interior of a refrigerator has a volume that's given, the temperature and the pressure are given. What is the mass of air inside the refrigerator? Okay, it's just the ideal gas equation. First, find the number of moles. So that's the pressure. Because it's in kilopascals, change it into pascals. And then you have the temperature, which is in Kelvin, so there's nothing there. Once you get the number of moles, you find the mass because you have the grams per mole. And on doing that, you get 749.5 or 750 grams. Now, the ability to do these problems simply means that you're able to just substitute and know which equation to use. And the last one. No, that is 5 and 6. Okay. The walls of an ice chest are made of 2 centimeter thick styrofoam with thermal conductivity. So when you see that, you understand, hey, this is a problem to do with conduction. The surface area of the chest is given. There is 4 kilograms of ice in it. And the temperature outside is 20. So you're trying to keep the ice from melting. Right? And that's why the question is, how long does it take the ice to melt? And the latent diffusion of water is given. But that's given in calorie per gram. And you have to know that 1 calorie is 4.186, okay, joules. But since it's a calorie per gram, it's going to be, per kilogram, it's going to be 4,185. Okay, we'll do that later. But the idea is, for ice to melt, the quantity of heat required is given by Q is equal to mass times latent heat. So here I've changed calories into joules per kilogram. All right. And then for conduction, here is the formula. K is the thermal conductivity, A is the area. You have all of those quantities. Just a matter of substituting. D is the thickness, which has to be in meters. So we get 36 joules per second. And then since it's the quantity of heat, it's mass times latent heat, we have the latent heat, and here this has to be actually in kilograms because it's latent heat. So once you do that, you get the total heat required, and so the time required is just this divided by this, because this is the amount of heat coming in per second, isn't it? And you need this much heat. So divide it, you get it in seconds, and then convert it into hours. So when you do a problem, you have to get the idea to do the problem first without, just guessing and using any formula you like. And getting the idea is the physics part. On to the last one. Here you have a 2 kilogram block of aluminum, which is at 50 degrees Celsius, dropped into 5 kilograms of water at 20. What is the change in entropy? The specific heat of aluminum is given. Once again, that's in calories per gram Kelvin. Okay, here the hot object loses heat, the cold one gains heat. We have to first find the final temperature. So let me just, so heat lost by aluminum is its mass times specific heat times change in temperature. Now for the first part, we can keep it in calories as long as it's consistent on both sides. Here you have the specific heat of water, which is 1 calorie per gram Celsius. So now there is a negative sign because I've taken this to the other side, becomes negative. And there's all these mathematical steps which you should be able to understand, and you get the final temperature as 22.43 degrees Celsius. Take a look at that right there and see if you get that. Once you get the final temperature, we try to find the change in entropy. We know that the change in entropy is quantity of heat lost or gained by the average temperature. So for aluminum, this is the quantity of heat lost or gained for aluminum is 4185 multiplied with its change in temperature divided by, this is the average temperature in Celsius, plus 273 to change it into Kelvin. Because aluminum started at 50 and finished at 22.43, right? And the negative, of course, mathematically that's going to be negative, but it also means that it loses heat, so the entropy changes, decreases. So you get that as negative 164.2. Now similarly, the increase in entropy of water is its mass times specific heat. Now see that here I've changed the calories into joules in both of these cases because you need it in joule per Kelvin. So that's how you change into joules. All right, 1 calorie per gram is 4,185 joules per kilogram. So once you do that for water, you get the increase in entropy and then find the net change in entropy. This is a decrease, this is an increase, so find the net change in entropy. So that's how you do these problems. Thank you, and make sure you study those for the final exam.